Okay, continuing right along, I replaced the display. I put a 4x20 line display on there just so I can have like all the parameters shown on the screen without having to toggle between screens or whatever. Once again, just as a review, going over to look at the circuit board. Got the regulator with the heat sink, the analog devices, ADE chip on an adapter that goes from surface mount to 20-pin dip. You can see right to the left of it there is the clock oscillator and a few calibration components, potential transformer, current transformer to sense the voltage and current. Okay, let me pan back here. There's the new display. You can see that the E on the top line there in the upper left corner is watt hours to 3 decimal places. This is useful for calibration against a standard. It's just basically the raw output of the energy register, which has been scaled to produce a watt hour. 1,000, 1.000 is 1 watt hour. Okay, on the other side of the display then we have kilowatt hours. As soon as it reaches 10 on the watt hour E value, it'll increment the kilowatt hours and you'll have 0.01 kilowatt hours or 10 watt hours at that point. On the bottom line have the RMS amps and the volts AC. The volts AC is a little bit of a nervous because there's an offset in the channel I'm going to have to calibrate out. It doesn't show up in the multiplying for power, but it's there and I'm going to have to write a number to a register to get rid of that. Watts, you can see, will appear on the line below that. Don't have any watts right now because I'm going to use the pulse output, kilowatt hour output of the ADE chip and measure the frequency of that and translate that to watts. That's the more accurate way of doing it because there's a lot of ripple in the actual watt register in the ADE chip itself. Okay, when I get the components installed, I gotta solder them in later. The solar DC voltage and current will go on the bottom line of the display. I put the t-shirt under it because I was getting some glare from the window and it makes a better picture with the t-shirt because it doesn't reflect as much. And right now you can see we have 14 point some odd watt hours and that comes to 0.01 kilowatt hours. And as soon as that reaches 20, it'll of course increment to 0.02 on the kilowatt hours. And that's what we have so far. I guess the next step will be to connect it to the server, sitting back there all by itself, and see if we can put the values we have now on the web page. We'll do that, and then we'll get into the actual watt calculation later. Up here on the frequency counter, I have the CF pulse output of the ADE chip. I am at 9.6 kc, and I can scale that frequency, and I'll measure that frequency to and translate that to watts instead of using the watt register with the ripple. That's a much more accurate way to do it. And I guess that's all we have for now. Thanks for watching.